Hi, my name is William Wu, and today we'll be talking about the idea of divide and conquer. Now, when we talk about divide and conquer, we are talking about a problem-solving technique, which usually involves breaking down a big problem or dividing it into smaller problems, and then by conquering each of them, we find the final solution. Now, you will ask, why do we want to do the breaking down and conquering bit? Well, here's an easy representation. For example, in this case, this is us, and this well-defined line, let's call it the scope of the problem. Now, since the scope of the problem is clear and well-defined, we will be able to look at the problem as a whole. We know the big picture. Now, therefore, we're happy. We know how to solve this. But considering this case, the scope in this case is vague, or sometimes it's just too big. We don't know where to stop. We don't know the full picture of the problem. Therefore, we cannot solve it by just looking at the problem. We have to go through this divide and conquer method. Let's see divide and conquer in action. Suppose we have a linked list structure with nodes containing integer, which is defined here. Struct node, it contains the data, which is an integer, and a pointer next to another node. Suppose this is the representation. And we have to write a function called delete odd that takes in a list and returns a new list with all the odd values removed. Suppose we have a function, and we're going to step through the function calls one by one. So in the first case, our first function call will be delete odd. Suppose we just take in 2. We are taking in 2. That means we're taking in this whole list in it. So at this point, node is pointing to 2. And whatever is after it, we are going to call it node next. And because node at this point, node is 2, so its data is even, so it will step through the first block. It says node next equal to delete odd node next. And here, we call the function again. This is why it's called recursive. We call the function again, but with a smaller subset of the node, of the list, sorry. So in this case, node next is this bit, so it will be another function call. Delete odd, and in this case, the first one will be 31. Do this, it will be 31. At 31, node will be pointing to 31, and whatever it is node next. Because it's odd number, we're going to return delete odd node next. So we'll be calling the function again, delete odd. In this case, the next one is 14. So right now, node is pointing to 14, sorry, and whatever it is next to it is node next. Okay, at 14, we are going to come back to here because 14 is even. So 14 next is equal to delete odd node next again. So in this case, it will be just 7. 3, we have to delete odd 7. And when it comes to 7, I think we can kind of stop calling functions. We have node 7 here pointing to null. At 7, it will call delete odd again, but we're running out of space, so I will just stop doing that. Delete odd, because node next in this case is null, and we catch null at a base case. This is very important. When node is null, it returns null. So when it's null, it will return null. And this is function call 3. Function call 3 is called when we are up to 14. And at 14, we assigned the return value to node next. So this function call, it essentially returns null. Come back to here, we will get 14 pointed to null. Let's keep going. 14 is called in this place, it's a 31. So it is an odd number. It just says return delete odd node next. And we already figured out delete odd node next, just return 14 and null. So at this point, it will still be 14 and null. All right, let's keep going. We just managed 31. It is called in the first case, which is 2. So 2 is an even function, and we assign 2's next to this function call, which is essentially function call 1. We are returning it. Therefore, 2 next will be whatever returning function we have here. It will be 14 and null, and essentially a return node, which is this whole thing. And this list, a new list supposedly, is the original list with all the odd numbers removed. Thanks.